Chemical reactions and equations. Chemical equations. Do you know learning chemistry can be fun? Well, most of us look at the equations in a puzzle manner and seems that they don't make any sense. Let us meet a few members of the chemical world and get introduced to them. Wow! I see a whole lot of them coming towards us. Let us get introduced. Hi there! I am an equation. I'm not alone. I have with me my colleagues called reactants and products. The physical state of the reactants and the products are also mentioned in the chemical equation. The notations like G, L, S and aqueous are written in brackets after the symbol of the reactants and the products. The symbol upward arrow may be used to denote the gaseous product, while the downward arrow may be used to represent the precipitate. Unless it is necessary to represent the physical states, they are generally not included in the chemical equation. Certain reactions that are carried out under controlled temperature and pressure are indicated in the chemical equation. What are chemical formulae? The shorthand notation in which elements are represented is called as formulae. For example, sodium is written as Na and chlorine as Cl. That's not all. Chemical formula of a compound indicates the number of atoms constituting it and number of each constituent element. Let us take an example. We know that the formula of water is H2O. That means a molecule of water is made up of two types of atoms. One is hydrogen and the other one oxygen. So, this clarifies the first point, which reads the numbers of atoms constituting it. Now, in water, that is H2O, 2 symbolizes 2 atoms of hydrogen, and since there is no subscript for oxygen, it means there is only 1 atom of oxygen. Hence, total 3 atoms form 1 molecule of water. Let us study the names and formula of simple compound. Look carefully at the formulas. You will notice that the metals are written on the left-hand side, while the electronegative elements on the right-hand side. That seems okay till now. However, how are the names of compounds derived? Well, it is remarkable to note that the name of the electronegative element changes with the suffix IDE. That means CaO is not read as calcium oxygen but as calcium oxide. FeS as iron sulfide instead of iron sulfur. NaCl as sodium chloride instead of sodium chlorine. Let us move to the molecular compound. Molecular compounds are formed by covalent bonding. We know that the atomic number of carbon is 6. Hence, carbon can share these 4 electrons to gain octet. We know that chlorine needs 1 electron to gain octet. Hence, carbon can combine with 4 chlorine atoms to form carbon tetrachloride. Each chlorine atom shares 1 electron with carbon atom. Hence, with a pair of electrons, a covalent bond is formed. As seen earlier, HCl reads as hydrogen chloride, CCl4 as carbon tetrachloride. Now, observe the second example of carbon tetrachloride. It says tetra as 4 chlorine atoms are involved in the bond formation. Similarly, there are other compounds that need prefix. Prefix is a word added before the name with no gap. Some example of prefixes are mono, di, tri, tetra, penta. Let us take a common example. Carbon monoxide means 1. Carbon dioxide, phosphorus trichloride, and dinitrogen pentoxide. Remember, if hydrogen is the first element in formula, no prefix is added. Example, H2S is known as hydrogen sulfide and not dihydrogen sulfide. A few binary molecule compounds names have been accepted by their common names. For example, H2O is actually hydrogen monoxide. However, H2O is better known by the common name water. NH3 is actually nitrogen trihydride. However, NH3 is better known by the common name ammonia. Let us now understand how the formula of ionic compounds are derived. When we talk about ionic compounds, then there has to be two charges, positive and negative. While writing formula for ionic compounds, the positive charge element or cation is written first, followed by the negative charge. Symbol of magnesium cation is Mg to the power of positive 2. Symbol of chloride anion is Cl minus. Now, number of positive charge should be equal to the number of negative charge. Hence, if magnesium is plus 2, then we also need 2 negative charge. Hence, we would need 2 atoms of chlorine. So the formula becomes MgCl2. Note, charge on atoms are not indicated, or just cross the charges to get the formula. Hence, the formula becomes MgCl2. Check the charge. Magnesium has plus 2 charges and chlorine has minus 2 charge. Hence, the charge gets nullified. Remember, the number of atoms of an element on the left-hand side should always be equal to the number of atoms on the right-hand side. This is law of conservation of mass. Let us then try to balance the equation. But before that, take a look at the following examples. To begin with, we need to identify the different atoms of elements participating in the reaction. In the above reaction, we have 2 different atoms of elements, namely hydrogen and chlorine. Let us identify the total number of atoms of each element on the left-hand side and right-hand side. Number of hydrogen atoms on the left-hand side equals to 2. Number of chlorine atoms on the left-hand side equals to 2. Number of hydrogen atoms on the right-hand side equals to 2. Number of chlorine atoms on the right-hand side equals to 2. Hence, this is a balanced equation. Let us identify if the following equation is balanced. Take a look at equation 1. Number of zinc atoms on left-hand side equals to 1. Number of hydrogen atoms on the left-hand side equals to 2. Number of sulfate atoms on the left-hand side equals to 1. Number of zinc atoms on the right-hand side equals to 1. Number of hydrogen atoms on the right-hand side equals to 2. Number of sulfate atoms on the right-hand side equals to 1. Hence, this is a balanced equation. On the other hand, equation 2 has number of sodium atoms on the left-hand side 1, number of hydrogen atoms on the left-hand side 2, number of oxygen atoms on the left-hand side 1, number of sodium atoms on the right-hand side 1, Number of hydrogen atoms on the right hand side, 3. Number of oxygen atoms on the right hand side, 1. This is not a balanced equation. This equation is called as skeletal equation. Now, let us try balancing the following reaction. There are a series of steps that are involved in balancing the reaction. Step 1. We need to identify the different types of atoms present in the equation. In the following reaction, the identified atoms are iron, Fe, hydrogen, H, and oxygen, O. Step 2. Identify the element that has the largest number of atoms either on the reactant side or the product side. Here we identify Fe2O3, of which oxygen has 3 atoms. Number of oxygen atoms on the left hand side is 1 and number of oxygen atom on the right hand side is 3. That means we need 3 atoms of oxygen on the left hand side. Hence, we add a coefficient 3 to H2O, that is water. Hence, the equation is partially balanced. Remember, you can add a coefficient to the equation but not a subscript. Here, 3 is a coefficient. What we cannot do is add 3 as a subscript to oxygen, so that the reaction would be step 3. Now, we take the second atom to be balanced, that is hydrogen. Number of hydrogen atoms on left hand side is equal to 6. Number of hydrogen atoms on the right hand side is equal to 2. To equalize the number of hydrogen atoms, we add the coefficient 3 to the hydrogen atom on the right hand side. This is what our equation looks like now. Now, we have the number of oxygen and hydrogen atoms balanced. The last element to be balanced is iron. Step 4. Number of iron atoms on left hand side is equal to 1. Number of iron atoms on the right hand side is equal to 2. Hence, we need to add a coefficient 2 to the left hand side iron atom so that the number of iron atoms are balanced. This is our final equation. Step 5. Let us check if the equation is completely balanced. Number of oxygen atoms on the left hand side is 3. Number of oxygen atoms on the right hand side is 3. Number of hydrogen atoms on the left hand side is 6. Number of hydrogen atoms on the right hand side is 6. Number of iron atoms on left hand side is 2. Number of iron atoms on the right hand side is 2. This is a perfectly balanced equation.